Alright, so for some reason or other the thing kicked us out, the program. So we were speaking about, that was the last thing we were speaking about, no? The complementary events that they add up to 1. So in example 3, and example 3 is on page 409. Okay. If 3 coins are thrown, so to draw the tree diagram, we don't have to draw a tree diagram. It just makes it a bit easier. So if you look at the first coin, what are the outcomes? Could either be heads or tails. You understand that part of the tree diagram? Yes. Right. So these are the branches. That's why it's called a tree diagram. Okay? These are the branches. Okay? So this part here of the branch is 1 out of 2, and that is 1 out of 2. The chance of you flipping a heads, this was 2 outcomes. It's either heads or tails. So the chance of you lying on the heads is 1 out of 2. The chance of you lying on the tails is 1 out of 2. Make sense? This is your first event. Okay, that girlfriend, is she okay then? Okay, it looks like she was sleeping, no? But I could be wrong. So, importantly, this is your event 1, or coin 1. So, if you toss a heads on your first coin, what are your options, or what are your outcomes for the second coin if you heads first? Heads or tails? Which is 1 out of 2, or 1 out of 2. And tails? It's again heads or tails. Again 1 out of 2, 1 out of 2. Do you understand that part? Okay? So this is the second event. So the third event, it can again be heads or tails. Heads or tails. Heads or tails. Heads or tails. So you'll be 1 out of 2, 1 out of 2. You understand? So what didn't you understand prior to this?
When you played the video game, I just got lost, but I understand how to do it.
You understand now? Okay. So the outcomes works like this. You have hit head first, on the first toss, on the first coin, heads again, heads again. Can you see that? And then heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Heads, tails, heads, heads. Tails, heads, tails. Tails, tails, heads, and so on. You understand? To what again? To red, okay. So what happens is, the outcomes, you can hit on the first coin a heads, second coin a heads, and the third coin a heads as well. Can you see that? This is heads, heads, heads. Or, these are your outcomes. No, what it could have been. It can be a heads, heads, tails. Heads, heads, tails. You see that? And so on and so on. So it's going to be then heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. These are your possible outcomes. Understand? Now the first question says, what is the probability of throwing 3 heads? So what's the probability of throwing 3 heads? It's only this one here. Not so. So it's going to be the probability of 3 heads. It's going to be half times half times half, which is 1 over 8. B. Throwing a heads and 2 tails in any order. So it says heads, whoops, heads and 2 tails in any order. So what are the options? 2 tails, it's going to be heads, tails, tails. Tails, heads, tails. Tails, tails, heads. Those are the outcomes there. that suits what they're looking for. Not so. So the probability that you got a heads, tails, tails, plus the probability of tails, heads, tails, plus the probability of tails, tails, heads. That will simply be, this is going to be 1 out of 8 plus 1 out of 8 plus 1 out of 8. How do I get 1 over 8? It's going to be a half times a half times a half plus a half times a half times, and so on and so on. You guys understand? So that's going to give you 3 out of 8. Okay. Any confusion there? You need question C. Throwing at least 2 tails. Sorry, 2 heads. Would I consider triple H? Yes. This one, HHT? Yes. This one? Yes. No. Yes. In other words, the probability there is simply 1 out of 8 plus 1 out of 8 plus 1 out of 8 plus 1 out of 8, which is 4 eighths, which is on. Okay, any confusion there, people? Any confusion? No. Right, which page are we on? 407, I think. 409. Okay. So we looked at question example 1, 2 and 3 at this point. You have dealt with exercise 2.14. So your homework is going to be the even numbers of 2.14. Okay. 12.4, sorry. Sorry, man. Now we're looking at dependent events. Dependent. So what we have dealt with prior to this is independent events. Now, the one event is dependent on the other. To explain to you basically what's happening there is that the basic example that I can come to mind now is that if you have balls in a bag, okay, or discs in a bag, alright, and on your first event, oops, that's not the bag. Yeah. This is the bag around. Alright. If you have 5 balls in the bag, and you take one ball out, then how many bags we have? How many balls we have here? 4. Not so. So when you do the second draw, how many balls will you have? 4. So on the second draw is dependent on whatever you draw on the first. You guys understand? However, in the previous exercise, what happened was the ball gets replaced or the ball gets put back in the bag. So when you do the second draw, how many balls will you have? Still 5. So irrespective, if the first, whatever you have drawn on the first account, it doesn't affect what you draw on the second account. Does it make sense? Whereas dependent events, it depends on what you draw in the first draw. It will affect your probability of your second draw. You guys understand? No? You'll understand it better in an example as well. So here we are told in the section, we look at the situation where the probability of one event is dependent on the outcome of the other event. For example, if a card is drawn from a pack of cards and not returned to the pack, then the probability of the next card drawn is altered. Okay? It depends on what happens in the first draw. Okay? It will affect your outcome of the second draw. Okay? So now we're looking at the example on page 412. So here we are told, we're going to draw this one together now. Here we are told a bag contains 9 balls. 5 are white, the rest are black. Okay, so when we're going to draw the tree diagram, and when we draw these, when we're busy with dependent events, drawing a tree diagram is going to make our life much easier. If you had done exercise 12.4 without a tree diagram, it was possible to do it. Whereas for dependent events, it's going to make your life so much easier if you draw the tree. If you don't, it's going to make it more complex. Okay. So a bag contains 9 balls. 5 are white, the rest are black. So what would be the probability on the first branch? 5 are white, the rest are black. 5 over 9. Remember, these branches must always add up to 1. So it's going to be 5 over 9 for white, and black 4 over 9. Okay, any confusion here? No. A ball is taken out and not replaced. Not replaced means what? Not put back before you do the next thing. Then the second ball is taken out. Calculate the probability. Now, before I go into anything else. So this is the first event happening here, not so. So if you draw white on your first event, you draw a white ball on your first event. What are my outcomes? It can either be white or black. Not so. So what is the probability? Okay, how many balls are there left in the bag now? If I draw one white, 8. Not so. But what's the probability of you drawing a white on the second row? If you had drawn white on the first row? Huh? 4. Why 4? Just one less. Not so? What's the probability of you drawing a black on the second row? You all okay with that? Now I want you guys to draw this branch for me and write in the probability for the second, for that branches. Okay, so what would that be? White? What's the probability of you drawing white? 5 over 8. Not so. Why? Because right now I've drawn one black. Okay? So I got 5 over 8, and how many blacks are left? What's the probability of drawing black on your second row? 3 over 8. What are my outcomes? What could it have? What are the possibilities? It could be white, 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 black, black, white, black, black. You all agree with that? Let's look at the first question. Let's calculate the probability that in the first case both balls taken out are black. So what's the probability of both being black? It's 4 over 9 times d over 8, which is 5 over 1 over 6. You all agree with that? Let's go with the second one, B. Is there anybody that's confused? B. Only one of the balls taken out is black. It says only one of the balls. So what is the probability there? Black, white, plus white, black. Write that calculation in there quickly. That will be what? You follow this branch here. Black, white. It's going to be 4 over 9 times 5 over 8 plus. White, black. It's going to be 5 over 9 times 4 over 8. What does that work out to be? It's 20, 40 over 72. You go 20 over, the 4 can go into 5 over 9. You guys understand? Any confusion thus far? You are moving too fast? No. Okay. The last one. At least one of the balls taken out will be black. At least one of the balls taken out will be black. So it could be black, white, plus white, black, plus the probability of black, black. Not so? So work that out. Probability of black, black is 4 over 9 plus 3 over 8. People, the probability of black, white and white, black, we have worked out already. Not so? So that's why I'm not going to work it out again. So that gives us an answer of 17? 13 over 18. You all agree with that? If I wanted to apply the complementary event, what would that be? There is going to be 1 minus the probability. You see, at least one black is that thing. Not so? The probability of no black is the same as the probability of 2 whites. Not so? So we can say 1 minus probability of 2 whites is 5 over 9 times 4 over 8. Work that out, somebody? 13 over 18. Can you see the same thing? So later on, when the sum becomes much, much bigger, it's going to make sense to understand how the complementary event works. Okay? You guys understand? No? Any confusion at this point? No. Okay, the recording is still holding out. Homework exercise 12.5. You do for me the odd numbers out of exercise 12.5. Now we're looking at two-way table for independent and dependent events. Two-way table, and this is the last part of your probability. So we are told two-way tables display the number of outcomes of each event. The various probabilities probabilities can then be calculated from the information in the table. In these examples, we will look at data rather than probability experiments. Okay. So now we're going to look at raw data basically. Okay. And not probabilities as we dealt with before. But it will link still into the probability, because as we know, the probability, to calculate the probability, is number of favorable outcomes over number of possible outcomes. Okay. So we'll carry on with this tomorrow. Then you guys are going to vote now for some reason or other. Sorry? Oh, it's at the end of the day. Okay. So you go to your period 6 and then you go vote in that last register. Okay. People enjoy the rest of your day. Good afternoon, class.